Hi there, this is a static equilibrium examination style problem. It's actually probably, a little bit above the scope of the A level in terms of how we're going to approach this question. But basically what I want you to do is to calculate T1 and T2 in this example given, but I want you to do it by using simultaneous equations. Okay? So if you want to pause and have a go at that and try and calculate T1 and T2, that'd be really good. And then I shall show you where to get the simultaneous equations from. If you need help up to that point, once you've got the equations, you can then carry on and have a go from there, or you can continue to watch and I'll take you through the entire problem. Okay, so first of all, what we need to do in terms of the simultaneous equations is to resolve the vectors T1 and T2. So let's start with T1. So I'm going to make a triangle. So we could split T1 vertically upwards, because obviously T1 will act in that direction, vertically upwards and to the right. And T2 acts obviously diagonally to the left. So we could also resolve that upwards vertically and then horizontally to the left. Now, it's very apparent that the horizontal component of tension 1 and the horizontal component of tension 2 must be equal and opposite because the system is in equilibrium. So T1 to the right, so we've got the angle there, the 60 degrees, so that adjacent component at the top. So that would be, so the first equation that we're going to do would be T1 cos 60, so that's the force going to the right, must be equal to T2 cos 40 going to the left. So T2 cos 40. So what we've done there is resolve horizontally, and that is our first equation. So I'm going to try number 2 now. So what we're going to do now is resolve vertically. So for T1, first of all, we've got T1 is opposite the 60 degree angle, so T1 sine 60. So T1 sine 60. Plus we've got the vertical component of tension 2, so that would be T2 sine 40. So if we add them together, T2 sine 40, those two components acting upwards, so that would be that one and that one, those two components acting upwards would be equal to the force that's acting downwards. So the two forces acting up must be equal to the force acting down. So T1 sine 60 plus T2 sine 40 must be equal to 10 kilograms. So we need to do 10 times 9.81, which is 98.1. So there's our two equations. If you want to try and solve for T1 and T2 now, if you didn't get that, please feel free to pause and continue. And what I'm going to do is obviously go through the answer anyway. So what I want to do is to rearrange the first equation. So the first equation to find T1. So T1 is simply T2 cos 40. So T2 cos 40 divided by cos 60 divided by just tidy that up, divided by cos 60. And then what I'm going to do is to substitute that rearranged equation 1 into equation 2, so into T1. So number 2. So instead of T1, I'm going to write T2 cos 40 divided by cos 60 times sine 60. So sine 60 at the top, plus T2 sine 40 equals 98.1. Okay, and then what we need to do is obviously to factorize this and find T2. And once we've found T2, we can then substitute back into another equation and find T1. So T2, let's factorize. So T2, open bracket. So we've got cos 40 sine 60 divided by cos 60 plus sine 40, close bracket, will equal 98.1. Therefore, T2 is simply 98.1 divided by that entire bracket. Okay? So if you do that, so if you do 98.1 divided by the cos 40 sine 60 over cos 60 plus sine 40, you'll get a T2 that is equal to 49.8 newtons. So that would be 98.1 divided by that bracket. Okay, so that'd be 49.8 newtons for T2. Then once you've got T2, it's really simple to find T1. So T1, if we use equation 1, would be equal to T2 cos 40 divided by cos 60. Okay, so T2 is 49.8 times cos 40 divided by cos 60. And if you put that in your calculator, T1 will be equal to 76.3 newtons. So there's your two answers. If you got them using that method, that's excellent, well done. And if you need a little bit of help, as long as you've got there in the end, that's fine as well. If you've really struggled and you've gone and just followed the answers, what you could do is rewind the video and attempt the question again, and then hopefully you'll be okay after that. Okay? Right, thanks for watching anyway, and I'll speak to you soon.